Hi students, this is Alex here. In this video, we are going to find the half-range Fourier cosine series for the given function f of x. As a first part, we are going to write the formula. So f of x equal to a naught by 2 plus summation n is from 1 to infinity a n into cos n pi x by L. Now to find a naught, we use a formula 2 by L integral 0 to L f of x dx. But f of x is made up of two parts. So first part is from 0 to L by 2 and f of x is kx dx. And second part is we have from L by 2 till L and it is k into L minus x dx. So we are going to integrate this. We write 2 by L and k is a constant that can be taken outside. X integration is x square by 2 and first part we have 0 to L by 2 as our limit. And even in the second part we can take k common, so 2k by L outside. Then L integration is Lx and x integration is x square by 2. So we have limit from L by 2 till L. Now applying the upper limit minus lower limit, so here it is 2k by L and first part will become L square by 2 and there is one more 2, actually L square by 2 whole square, so L square by 4, there is one more 2, so L square by 8 and lower limit is 0 and coming to this it is 2k by L. Now applying upper limit L into L, so L square, then L square by 2 minus applying L by 2, so L into L by 2 is L square by 2 minus L square by 4 by 2, so L square by 8. So we completed the substitution of upper limit minus lower limit. In both the terms we find 2k by L common, so we can take it outside. We have L square by 8. Now this is L square minus L square by 2. We're taking this minus sign inside plus, minus L square by 2 again, then plus L square by 8. Now we are going to combine the like terms. We have L square by 8, L square by 8. So we can add it together as a single term. So outside 2k by L we have written as it is, which is 2L square by 8. Then we have this L square, which can write it as it is. Then we have minus L square by 2 minus L square by 2. By adding that we get minus 2L square by 2. And we can cancel these two and we see plus L square minus L square, we can cancel those also. After that we have only a naught as 2k by L into 2L square by 8. So 2, this will become 4. Again if I cancel, this will become 2 and we can cancel this. So we left with KL by 2. So we completed a naught, which is KL by 2. Now we are going to find AN. Now coming to AN, our formula is 2 by L integral 0 to L f of x into cos n pi x by L dx. And now we are going to split this into two parts. 2 by L integral 0 to L by 2 first, and it is kx into cos n pi x by L dx. And the second part, it's ranging from L by 2 till L, k into L minus x into cos n pi x by L dx. Now we are going to continue the Bernoulli's formula. So we have x and cos n pi x by L. So k is a constant, we can take it outside. Again we have these two terms. So coming to the first part, u is x and v is cos n pi x by L. U dash is 1. V1, this integration is sin n pi x by L by n pi by L. And u double dash will be 0 and v2 will be minus cos n pi x by L by n pi by L whole square. In the same way, coming to the second part, u is L minus x and v is cos n pi x by L. So u dash will be minus 1, u double dash will be 0 and v1 will be sin n pi x by L by n pi by L and v2 will be minus cos n pi x by L by n pi by L whole square. Now the Bernoulli's formula is u v1 minus u dash v2 plus u double dash v3 dot dot dot. So we are going to apply this formula. So an becomes, outside we have 2 by L. Applying this formula for the first set of terms, it is x into sin n pi x by L by n pi by L. So by n pi by L minus u dash, which is 1, but v2 there is a minus sign, so I make this as plus cos n pi x by L by n pi by L whole square. Coming to the second set of terms, again we have 2 by L and there is also a constant k outside. Now this will become L minus x into sin n pi x by L and minus u dash. U dash is minus 1, so it will become plus, but again there is a v2, there is a minus sign. So we take minus cos n pi x by L, n pi x by L by n pi by L whole square. So this is from 0 to L by 2. Second part is from L by 2 till L. Now substituting the limits. So an becomes, we have 2k by L. Now L by 2 into sin. If I put L by 2 here, LL gets cancelled. So I get sin n pi by 2 by n pi by L plus, if I put L by 2 here, I get cos n pi by 2 by n pi by L whole square. When I put the lower limit, first part is 0 because there is an x and sign. Second part will become 1. So 1 by n pi by L whole square. Now coming to the second set of terms, we have again 2k by L outside. When I put L here, L minus L is 0. When I put L here, this will become cos n pi, which is minus 1 whole power n by n pi by L whole square. Coming to the lower limit, I take a separate bracket. L minus L by 2 is L by 2. And when I put L by 2 here, I get, after cancelling L, sin n pi by 2. So sin n pi by 2, then, and even there is a denominator term here, by n pi by L, like which is similar to the first term, and we should also write that one. So n pi by L, and now putting L by 2 for this, after cancelling L and L, we get cos n pi by 2. So minus cos n pi by 2 by n pi by L whole square. So close this bracket and finally close the bigger bracket. So cos n pi by 2 by n pi by L whole square. Now let's simplify this. Totally there is 2k by L common. After that, we can take this term L by 2 into sin n pi by 2 by n pi by L. That L goes to the numerator as L square because already there is one L. Here cos n pi by 2 by n square pi square by L square. So L square I keep it here. Then minus 1 by n square pi square by L square. So L square I take to the numerator. Then again this will become minus of minus 1 whole power n by n square pi square by L square. So L square I take it here. Similarly, this minus sign is taken inside. So minus L square by 2 into sine n pi by 2 by n pi. Then again this will become plus L square cos n pi by 2 by n square pi square, because L square I have taken to the numerator. So here we see these two terms are same with opposite sign. We can cancel. Then after that we have a like terms that we can add. So this is 2k by L. Now 2L square into cos n pi by 2 by n square pi square. Then minus L square by n square pi square, and again minus 1 whole power n L square by n square pi square. Now I can take L square common, so this will become 2k L square by L. Even denominator n square pi square also I can take common outside. So this is 2 cos n pi by 2 minus 1 minus of minus 1 whole power n. Now after getting this an, we are going to check for even and odd. Suppose if n is even, like 2, 4, 6 dot dot dot. So this an becomes 2k L square by L n square pi square. Actually you can cancel this L and square, so there won't be L in the denominator. So 2k L by n square pi square. When I substitute 2 here, we get cos pi. When I substitute 4 here, we get cos 2 pi. So it will become minus 1 or plus 1. So let us not substitute for this term because it is alternating plus and minus. So we keep 2 cos n pi by 2 as it is. But when I substitute 2, 4, 6 here, it will become positive. And already there is minus 1 here, and minus of it will become positive. So totally it is minus 2. So we left with this much. So when n is even, so we take when n is even. Similarly, if n is odd, like 1, 3, 5, what happens to an is, when I substitute odd value here, we get cos 1 pi by 2, cos 3 pi by 2, cos 5 pi by 2, everything becomes 0. And here when I substitute odd number, this will become minus 1, outside there is a minus, so plus, so totally all the term becomes 0. So when n is odd and an is 0, so it exists only for the even numbers. So now coming to our formula, that is f of x equal to a0 by 2. a0 we got as kl by 2. So substituting here kl by 2 and a0 by 2, so one more 2 I have to put in the denominator, plus summation. Now n is from even till infinity, and we have 2k L by n square pi square into 2 cos n pi by 2 minus 2 into cos n pi x by L. Now to change this from even to infinity as 1 to infinity, n is replaced as 2n. So f of x will become kl by 4 plus, now summation from 1 to infinity, we have 2kl by 2n whole square into pi square. N is replaced as 2n, and here it is 2 cos 2n pi by 2, because even here I replace this n as 2n, and we also have minus 2 at the end. Then outside we have cos 2n pi x by L. So every n I replaced with 2n. So our series changes from even to infinity as 1 to infinity. Now further we can simplify this. We can cancel this 2 and 2, and from this 2 can be taken common as outside. So this is kl by 4 plus summation n is from 1 to infinity. We have 2kl by, this is 4n square pi square. When 2 is common, after taking 2 outside, we left with cos n pi, then minus 1, and also cos 2n pi x by l. So this 2, 2 and 4 we can cancel, and constants can be taken outside. So kl by 4 plus constants are kl by pi square. Now we have summation n is from 1 to infinity. We have cos n pi minus 1 into cos 2n pi x by l. So this is the required Fourier series cosine series expansion, half range cosine series expansion for the given function f of x. And we also have this n square term inside the summation. So by n square, we have this n square. Because we have taken the constants around outside, but n square is inside the summation.